Thank you everyone for listening to my talk about simplified pressure sensor insoles. So let's clarify first maybe what these insoles are doing. They are insoles relatively similar to the ones you know. You wear them in your shoe, and the difference is they are equipped with sensors that measure pressure. So with this information you can obtain ground reaction forces and also the pathway of the center of pressure. Both these characteristics are highly relevant in assessment of postural control and also risk of falling, in addition to a number of other clinical purposes. And they are used during very basic activities like standing, jumping, landing, and gates. So one strength of these tools is that they are not space restricted. You have them in your shoe and you can walk freely around. A problem, however, is that they are really expensive. So product price prevents widespread adoption, and it is an interesting idea to reduce the sensor number in order to reduce the product price. Usually when this was done in previous research, the range of sensor numbers was within 5 to 13 sensors, and the selection was based on 9 to 10 zones of your foot. The problem, however, is that reduction of sensor number comes with a reduced measurement accuracy, and this effect was often observed to be task dependent. So the goal of previous research was often to reduce the sensor number with no or acceptable loss of accuracy, and we were wondering if there is a promising range of sensor numbers with which we can still achieve accurate measurements. We hypothesized that we could characterize the relationship between the number of sensors and accuracy, that we could find an effect of gate type on accuracy, and we wanted to detect a promising compromise between measurement accuracy and the number of sensors we use. So what we did is we measured 15 male subjects who were walking, jogging, and running in randomized orders at self-selected speeds along a straight line. And then we measured the data via a Kissler force platform, which is considered the gold standard for such measurements. One PETA-X pressure sensor insole consisting of 99 sensors, which is considered one of the most accurate insoles, and a 3D motion capture system just to be able to statistically control for movement speed. Now, the interesting part about the insoles is that we did not repeat measurements for each different layout, but within one trial, we took the same data, extracted only the information from 3 sensors, 5, 7, and so on, to compare the performance of different sensor layouts. With respect to statistics, we calculated root mean square error and coefficient of variation for descriptive purposes. We tested Pearson and concordance for the relationship and the exact agreement between sensor layouts and force platform. And we conducted ANOVA to test the effect of gate type. And then in the end, we used this equation to quantify what could be a promising compromise. Now let's have a look for the first slide of results. This is for the concordance, so the exact agreement between layouts and force platform data for the center of pressure. And what we see is that 4 out of 6 tests that we conducted showed significant differences between different gates. We found similar results for root mean square errors and also for ground reaction forces. So overall, 2/3 of all the tests conducted showed significant differences between gates. This is across sensor layouts. And now on the next slide, you see how the single layouts performed. So on the upper half of the y-axis, you see correlation coefficients. On the lower half, you see coefficient of variation for each single layout consisting of a different number of sensors. And what you can see is that there are non-linear trends that reach the plateau at around 11 to 13 sensors. And this is in line with what we found using this equation. We found that also this quantification confirmed a promising compromise at 11 and 13 sensors. So how do the actual data look like visually when we compare them? This is what you can see here. And what we did is basically running a regression model using the data from all subjects from the 11 sensor layout as a promising compromise. And then we applied the formula of the regression onto the subject with the median R. So this is considered the most representative one. It's not a very good one, not a very bad one. So you get a good impression how accurate this data was after applying the regression model, which estimated then the absolute ground reaction force based on the reduced number of sensors. And what you can see, they match quite well. This is probably in walking the worst result. And even here we have a relative root mean square error of 5%, which is not too bad. Like usually when talking below 10%, it's kind of acceptable. Okay, so to summarize, we found a relationship between the sensor number and the measurement accuracy. This relationship was non-linear, which allowed us to find a promising compromise. And this was found for the 11 and 13 sensor layouts, so that's an interesting range. For both these layouts, the correlation and also the concordance were very high. So we have data from the layouts that match very well with the forest platform data. However, we should keep in mind that, first of all, in this study, we focused on the sensor number, not the placement itself. So there are methods how to optimize the placement, and this should be done. If this works well, then you could even reduce the sensor number. And then second, we found an effect of gate type, but also differences between ground reaction forces and center of pressure. This is important to consider in the development of simplified layouts, because both these characteristics are relevant in practical applications. So for development and also for validation, the data should be accurate in both these domains. So this research from this study is just giving an idea in which range of sensor numbers to operate. Some recommendations include to optimize the placement itself for both ground reaction forces and center of pressure, to work within a promising range that we identified around 11 to 13 sensors. As I said, if the placement optimization is working well, then the sensor number could be further reduced. To include cross-validation, so with a different sample, and also to account for different gates or maybe even different tasks, because previously it was found that tasks have a different effect on accuracy. In case it is interesting for you, I prepared the references, and then I thank you for listening. Thank you.